Compute del z del x and del z del y, given the function x squared plus 4y squared minus 36z squared is equal to minus 19. So we first compute del z del x. To compute del z del x, our focus should be on the z and the x variables. Thus, all other variables will be treated as constants in this case. So here, y is going to be treated as a constant, right? So we now differentiate the function term by term. So we differentiate x squared with respect to x. We are going to have 2x. Then we now differentiate 4y squared with respect to x. That's going to give us 0 because y is now a constant in this case. Then we now differentiate minus 36 z squared with respect to x using implicit differentiation. So that's going to give us minus 72 z del z del x. Then it's equal to, when you differentiate 19, since it's a constant, we are going to have 0. So this is what we now have. Now let's simplify in group terms. So we are going to have minus 72z del z del x is equal to minus 2x. Now dividing through by the coefficient of del z del x, we are going to have del z del x is equal to minus 2x on minus 72z, which is giving us x on 36z. Thus del z del x is x on 36z. We now compute del z del y. So in this case, our focus should be on the z and the y variables, and in this case x will be treated as a constant. So differentiating x squared with respect to y is going to give us 0 since x is now a constant. Then plus, we now differentiate 4y squared with respect to y. That's going to give us 8y. Then minus, we differentiate 36z squared with respect to y using implicit differentiation. That's going to give us minus 72 z del z del y, and 19 is a constant, so that's going to give us 0. So grouping terms gives minus 72 z del z del y is equal to minus 8y. So dividing through by the coefficient of del z del y gives del z del y to be equal to minus 8y on minus 72z, and that's going to give us y on 9z. So that's the. In our second example, we have to compute del z del x and del z del y given the function x cubed z squared minus 5xy squared z is equal to x squared plus y cubed. Now here, note that we are to use the product rule in addition to the implicit differentiation. First compute del z del x. So in this case, we are going to treat all other variables other than del z del x as constants. So thus, we will treat y as a constant in this case. So now let's differentiate. So with the first term, we have the product of two functions. So we are going to apply the product rule. So let's keep x cubed, then differentiate z squared with respect to s using implicit differentiation. That's going to give us 2z del z del x. Now we now keep z squared, then we differentiate x cubed with respect to x. That's going to give us 3x squared. Now we now move on to the second term. So with the second term, we can factorize minus 5y squared out because that's a constant in this case. So minus 5y squared out. Then it will be left with x times z. So we now differentiate x times z using the product rule in addition to the implicit differentiation. So now let's keep x and differentiate z. That will give us del z del x. Plus we now keep z, differentiate x with respect to x. That's going to give us 1. then is equal to differentiate x squared with respect to x. That's going to give you 2x. Now you differentiate y cube with respect to x. In this case, y is now a constant, so that's going to give us 0. Now let's simplify further. 2x cubed z del z del x plus 3x squared z squared minus 5xy squared del z del x minus 5y squared z is equal to 2x. Now let's group the terms with del z del x on one side and the terms without del z del x on the other side. We are going to have 2x cubed z del z del x minus 5x y squared del z del x is equal to 2x minus 3x squared z squared plus 5y squared z. So we can now factorize the z del x from the left hand side. That will give us del z del x into brackets 2x cubed z minus 5x y squared is equal to 2x minus 3x squared z squared plus 5y squared z. To find del z del x, we just have to divide by the coefficients of del z del x. So we are going to have del z del x to be giving us 2x minus 3x squared z squared plus 5y squared z divided by the coefficients, and thus 2x cubed z minus 5xy squared. Let's now compute del z del y. So in this case, our focus should be on the variables z and y. All other variables will be treated as constants. So thus x will not be treated as a constant in this case. So with the first term, we are going to have x cubed out. Now we now differentiate z squared with respect to y. That's going to give us 2z del z del y. That's using the implicit differentiation. Then minus, so here we can now factorize 5x out. So 5x out. Then it will be left with y squared z. So we now differentiate y squared z using the product rule and the implicit differentiation. So let's keep y squared, then differentiate z with respect to y, and that's going to give us del z del y plus we now keep z, differentiate y squared with respect to y, that's going to give us 2y. Then it's equal to, we now differentiate x with respect to y. In this case, x is a constant, so that will go to 0. Then plus, we now differentiate y cubed with respect to y. That's going to give us 3y squared. So let's simplify further. So we are going to have 2x cubed z del z del y minus 5xy squared del z del y. 5 times 2, that's 10. Then x y z is equal to 3y squared. Now let's group the terms with del z del y on one side and the terms without del z del y on the other side. So we are going to have 2x cubed z del z del y minus 5xy squared del z del y is equal to 3y squared plus 10xyz. So factorizing del z del y out, we are going to have 2x cubed z minus 5x y squared is equal to 3y squared plus 10 10x yz. So we are going to have the z, the y to be equal to 3y squared plus 10x yz divided by 2x cubed z minus 5xy squared. So here we have to compute the z, the y, given the function as x squared sine of 2y minus 5z is equal to 1 plus y cosine of 6zx. So here we are going to use the chain rule, the product rule, and the implicit differentiation formula, right? So we are going to use all these three guys to solve this question. To compute the z, the y, we are going to focus on the z and the y variables, and any other variable will be treated as a constant. So in this case, x will be treated as a constant. So we can rewrite this question as x squared out sine of 2y minus 5z is equal to 1 plus y cosine of 6zx, right? So now let's differentiate this guy with respect to y. So we are going to have x squared out. Now when we differentiate sine, we are going to have cosine of x. So that will be cosine of 2y minus 5z. Then we now differentiate what's inside. That's, we are using the chain rule in this case. So differentiating what's inside with respect to y gives, so when you differentiate 2y with respect to y, we are going to have 2 minus, when you differentiate 5z with respect to y, we are going to have 5 del z del y. So with the right hand side, when you differentiate 1 with respect to y, you are going to have 0 plus, with the second term on the right hand side, we are going to use the product rule and the chain rule all together, right? So now let's keep y, then we differentiate cosine of 6xz. That's going to give us minus sine of 6zx. Then we use the chain rule to differentiate what's inside. So we are going to have 6x del z del y. Then we now keep cosine of 6zx, so that will be plus cosine of 6zx. Then we now differentiate y with respect to y, so that's going to give us 1. Simplifying the left hand side, we are going to have 2x squared cosine of 2y minus 5z, then minus 5x squared cosine of 2y minus 5z del z del y is equal to minus 6xy sine of 6zx del z del y plus cosine of 6zx. So we can now group terms. So we send all those guys with del z del y on the left hand side. So we are going to have minus 5x squared cosine of 2y minus 5z del z del y plus 6xy sine of 6zx del z del y is equal to cosine of 6zx minus 2x squared cosine of 2y minus 5z. So we can now factorize the z del y on the left hand side. So that will be del z del y out minus 5x squared cosine of 2y minus 5z plus 6xy sine of 6zx is equal to cosine of 6zx minus 2x squared cosine of 2y minus 5z. So we now divide by the coefficients of the z and the y. So our answer will be giving us the z, the y is cosine of 6zx minus 2x squared cosine of 2y minus 5z divided by minus 5x squared cosine of 2y minus 5z plus 6xy sine of 6zx. Alright guys, so thanks for watching. Hope this video is helpful. See you in the next video.